In this video, we'll let us solve some more problems on single random variable. Let us solve some problems. First problem, the random variable x is given as Gaussian and the mean value is 0 and the standard deviation is equal to 1. The random variable y is obtained from x using y is equal to 10x to the power 3. What is fy of 0.1298? We know the relationship between y and x is given. Y is equal to 10x to the power 3. So that is equal here, this gives you x is equal to y divided by 10 to the power 1 by 3. If y is equal to 0.1298 and then x value, when you simplify this, you get this as 0.2350 and this value fx of 0.2350 is always given by phi of, that is CDF, x of minus mu x divided by sigma x. Here mu x is 0 and sigma x is equal to 1. Therefore, it is phi of x, that is phi of 0.2350. So we need to find out phi of 0.2350. We make use of the Gaussian table which is given in Appendix B of Richard Williams book on probability statistics and random process for engineering. So using that table, we have obtained here for 0.23 it is 0.5910, 0.24 it is 0.5948. From this we can find out the slope, that is 0.5948 minus 0.5910 divided by 0.24 minus 0.23, and from this we can find out fx of 0.2350 using the equation. And here we get fx of 0.2350 is equal to 0.5929. We solve the second problem. The second problem states that the random variable x is uniformly distributed between 0 and 2. Y is given as 3x cubed. What is the PDF for y? First and foremost information what we have here is uniformly distributed. For a uniformly distributed function, the PDF is defined as 1 for the period 0 to 2. So now another data what we have got here is the relationship between y and x. It is defined as y is equal to 3x cubed. So therefore x cubed is equal to y by 3. So x equal to y by 3 to the power 1 by 3. This can be further written as y to the power 1 by 3, 3 to the power 1 by 3. When I differentiate this x with respect to y, I have this as 1 divided by 3, 1 by 3. It is 1 by 3 y to the power 1 by 3 minus 1. That gives us 1 divided by 3 to the power 1 by 3 multiplied by 3, and it is 1 divided by y to the power 2 by 3. So this gives you 3 to the power 4 by 3 y to the power 2 by 3. So you can get here, if you observe, dx by dy is equal to 1 divided by 3 to the power 4 by 3 y to the power 2 by 3. Next step is to find out the fy of y, the CDF of y, that is as good as finding out the fx of y divided by 3 to the power 1 by 3. So when we differentiate this fx of y by 3 1 to the power 1 by 3, we get the answer as fx of x, that's the PDF of this, and dx by dy. So here fx of x for a uniform distribution, fx of x is given by 1 divided by 2 minus 0, that is equal to half. So therefore we get fy of y is equal to differentiation of the PDF, that is d of dx of fx y by 3 to the power 1 by 3, that gives you 1 divided by 3 to the power 4 by 3 y to the power 2 by 3, and which is fx of x is given as half. So this is your answer, and this is valid for all the values of y between 0 to 24, because when x value equal to when x equal to 0, y equal to 0, when x equal to 2, y is equal to 3 into 2 to the power 3, that is equal to 24. Third problem, the random variable x is uniformly distributed between 0 and 5. The event b is b equal to x greater than 3.7. What are f x given b of x, mu x given b of x, and sigma square x given b? So this problem is on conditioned random variable, and the first data given is it is a uniformly distributed random variable x. So here it is uniformly distributed between 0 and 5. So PDF for x is fx of x equal to 1 divided by b minus a, that is 5 minus 0, that gives you 1 by 5, that is equal to 0.2. And once fx of x is given to you, and you know that the PDF can be found by integrating this fx of x with respect to x. So we have fx of x equal to x minus a divided by b minus a. For a given value of x, this can be written as it is x minus a is 0, b is 5, 5 minus 0. So therefore it is x by 5. Now probability of b, event b, is probability of x varying between 3.7 to 5. That is given by CDF of 5 minus the CDF of 3.7. Here fx of 5 is given by using this relationship. It is 5 divided by 5 minus 3.7 by 5. That gives you 0.26. Once we know the probability of b, we can find out the PDF x given on b of x is given by fx of x divided by probability of b, that is 0.2 divided by 0.26, that gives you 0.769. So once we know the PDF of x given of b, we can obtain the mean by integrating between 3.7 to 5, that is PDF is 0.769 x dx. So when we simplify this, we get the answer as 4.35. Once we know this, we can find out the expectation of mean square, that is E of x given b whole square is given by the integral of 0.769 x square with respect to dx over the period 3.7 to 5. When we simplify this, we get the answer as 19.09. By knowing the value of the expectation mean square and the mean, we can find out the variance. Variance of x given of b is given by e x given of b square minus e x given of b the whole square, that is 19.05 minus 4.35 whole square. You get the answer as 0.1355. Let us solve the fourth problem. Let x be an exponential random variable. If TDS is given by fx of x is equal to 1 minus e to the power minus x by 3 for all values of x greater than or equal to 0, and it is 0 for x less than 0. And event b is defined as x greater than 2. What are the PDF x given on b of x, mu x given on b of x, and variance x given on b? Now once the TDS is given to us, we can find out the PDF. Fx of x TDS is given, so we can find out fx of x, that is the PDF. It is the differentiation of the PDF with respect to x. So you get this, when you differentiate this, you get minus 1 by 3 e to the power minus x by 3. So you get this as 1 by 3 e to the power minus x by 3. And we need to find out probability of b. That is given by probability of x greater than 2, which means that x value can take anywhere between 2 to infinity. So therefore, we can find out this by having the CDF of at infinity minus fx of 2. So fx of infinity is 1 minus e to the power minus infinity minus 1 minus e to the power minus 2 by 3. So 1 minus 0 minus 1 plus e to the power minus 2 by 3, that gives you 0.5134. Using these data, we can find out the fx given on b of x. It is a ratio of fx of x divided by probability of b. Fx of x is given by e to the power minus x by 3 by 3, and probability of b is given by 0.5134. When we simplify this, you get this as 0.6492 e to the power minus x by 3. So similarly, we can find out the mean value x given on b of x by integrating the PDF f x given on b of fx with respect to x over the period 2 to infinity. When we simplify this and substitute these values, we get this as 4.999. And expectation of mean square x given on b whole square is the integration of the PDF multiplied by x square with respect to x over the period 2 to infinity. We get the answer as 33.997. By knowing these two values, we can get the variance x given on b is equal to, that is 33.997 minus 4.99 whole square. Answer is 9.0076. Let's solve the fifth problem. X is a Gaussian random variable for which the mean value mu x is 518 and sigma x is equal to 33. An event is defined, b is defined for b x value greater than 500. This conditioning of x can be accomplished, for example, by testing c probability of pass the test is equal to probability of b. what is the expression of f radius x given on B of x? So we know that fx of x minus mu x by sigma x is phi of 500. X is given as 500 minus mu x is 518 divided by 33. We get this value as phi of minus 0.5454, that is fx of 500. Using the table given in appendix 5 of Hilbert's form, we can find out the value corresponding to 0.54. It is 0.7054. Corresponding to 0.55, it is 0.7088. So 0.7088 minus 0.7054 divided by 0.55 minus 0.54 is equal to 0.7088 minus fx of 0.5454 divided by 0.55 minus 0.5454. Using this, we can find out fx of 0.5454, that is 0.707238. fx of x is given by 1 divided by root of 2 pi into x, that is sigma x, e to the power minus 500 minus 518 whole square divided by 2 into 33 whole square. From this, we can get the value of fx of x is equal to 0.0104. Now we can find out fx of x given of b of x is given by fx of x, that is 0.0104 divided by fx of b, that is equal to 0.7072. Answer is 0.0147. To solve the sixth problem, we have been given the discrete random variable x, where the PDF fx of x is equal to 0.25 delta of x plus 0.25 delta x minus 1, 0.25 delta of x minus 2, 0.25 delta of x minus 3. Here the event b is defined as x greater than 1. What are the PDF and CDF or conditioned by event b? And here P of B is probability of x greater than 1. X greater than 1, we have only two values here, 2 and 3. So therefore, it is equal to probability of x equal to 2 plus the probability of x equal to 3. Probability of x equal to 2 is 0.25 and the probability of x equal to 3 is equal to 0.25. So it gives you 0.25 plus 0.25, that is 0.5. Once we know PD, we can easily find out PDF f of x given on B of x. That is, this formula is given by fx of x divided by P of B. Now fx of x is defined here. It is 0.25 delta x. So first term will be 0.25 divided by 0.5 delta of x. Second term is 0.25 delta of x minus 1 divided by 0.5. Third term is 0.25 divided by 0.5 delta of x minus 2. The fourth term is 0.25 divided by 0.5 delta of x minus 3. We get this as 0.5 delta of x plus 0.5 delta of x minus 1 plus 0.5 delta of x minus 2 plus 0.5 delta x of minus 3. PDF can be obtained by integrating the PDF. When we integrating the PDF, we get all the impulse function will be converted into step functions. So therefore you have 0.5 u of x plus 0.5 u of x minus 1 0.5 u of x minus 2 plus 0.5 u of x minus 3. Thank you. In the next video, we'll move on to the module number 2, which is on bivariate random variable.